Good morning, class. Today we are going to discuss the topic of carbon anion. An organic anion with a negative charge on a carbon is called as carbon ion. It is generated by removal of an atom or a group of atoms from a molecule without the bonding electron. Formation of carbon ion. It may be formed by first condition is when a group or an atom departs from carbon atom without its bonding electron pair. Just see, it is the molecule of acetylene. When it comes in contact with base, this base abstract this photon. Because of that, the electron pair which is present in between carbon and hydrogen shifted over this carbon, and we got acetylene ion simply, which is carbon anion. Carbon gets negative charge. In this case, this molecule CO2 gets out to give methyl free radical, to give methyl carbanion. When negative ion attacks on multiple bond, suppose Y minus is a negative ion, and when it attacks on multiple bond, just see here is double bond. So this Y minus attack on this carbon. Because of that, this electron pair shifted on this carbon, and we got carbon anion. Now we are going to discuss stability of carbon ion. Tertiary carbon ion is less stable than secondary carbon ion, which is again less stable than primary carbon ion, which is again less stable than methyl carbon ion. It means that methyl carbon ion is highly stable. Electron withdrawing substituent such as carbonyl and cyanide groups enhance the stability of carbon anion due to the dispersal of negative charge, that is delocalization. Just see here, this CH2 negative attached with carbonyl group. Because of that, double bond in between this carbon and oxygen can easily shift on your oxygen, because oxygen is electronegative. Because of that, this bond can easily shift in between this and this carbon. Benzylic carbon ion is more stable than ethyl carbon ion because of resonance. Just see, in this structure, this negative charge can be shifted over this benzene ring, and because of that, this carbon ion is more stable than your ethyl carbon ion. Now we are going to see structure of carbon ion. The negatively charged carbon atom of a simple carbon ion is sp3 hybridized. 3 of the sp3 orbital forms 3 sigma bonds with the 3 substituents, whereas 4th contain non-bonding pair of electrons. Thus carbon ion is isoelectronic with ammonia, that is NH3. Therefore, they appear as a pyramidal in structure. So, just see here, your carbon is sp3 hybridized, and one of the hybrid orbital contain lone pair of electron. Now we are going to see reaction of carbon ion. First reaction is displacement type of reaction. So just see, this carbon ion attack this carbon. Because of that, this X minus goes away. So in this reaction we simply say that R minus displaces, that is this carbon ion displaces this halide, where R can be CH negative COOR by 2. Second type of reaction is addition reaction. Just see here, this carbon ion attack on this carbonyl carbon and add this molecule on this molecule. Now we are going to discuss another reaction intermediate, that is free radical. Free radical is an atom or a group of atoms containing odd or unpaired electron. Methyl free radical, that is CH3 dot, ethyl free radical, that is CH3CH2 dot, chlorine free radical, that is Cl dot, are some of the examples. Now we are going to see characteristics of free radical. Free radical are electrically neutral and highly reactive species formed by homolytic fission of covalent bond. They are paramagnetic in nature due to the presence of odd electrons. They are extremely reactive since they have tendency to complete the octet of the atom carrying unpaired electron. They are short-lived species. They are usually formed in a reaction which are carried out at a very high temperature or under the influence of ultraviolet light or in the presence of radical initiator such as peroxide. So here we see that chlorine molecule in the presence of ultraviolet radiation or under very high temperature condition gives chlorine free radical. Now we are going to see the structure of alkyl free radical. The carbon atom of an alkene free radical is sp2 hybridized. Its 3 hybridized orbitals are bonded to 3 atoms or groups of atoms. Thus, free radicals have planar structure and bond angle of 120 degree. The unpair of electron is present in unhybridized p orbital, which are shown here. So this is the structure of free radical. Here we see that this 3 line basically denotes sp2 hybridized orbital, which are in one plane, that is trigonal geometry, trigonal planar geometry. Angle between this hybrid orbital is of 120 degree. The unhybrid orbital contains, unhybrid p orbital contain single electron. Now we are going to discuss stability of free radical. Before discussing stability of free radical, we have to go from this reaction. For the formation of methyl free radical, delta H which is required, it is plus 426 kilojoule. For ethyl free radical, delta H value is 406 kilojoule. For propane free radical, delta H value is again 406 kilojoule. Now just see, it is the interesting thing which is happening here. It is normal propane free radical or primary free radical. From propane, when we form secondary free radical, delta H value is 393 kilojoule. For the formation of tertiary alkyl radical, in this case tertiary butyl free radical, delta H value is 380 kilojoule. So from this value we can say that the order of stability is tertiary alkyl radical is more stable as compared to your secondary alkyl free radical. Just see the value. Secondary free radical is more stable than primary alkyl radical. Primary alkyl radical is more stable than your methyl free radical. Now we are going to see preparation of free radical. First is by thermal reaction. So peroxide compound, just see it is benzyl peroxide. When benzyl peroxide is heated, it generates this free radical, which again give us this free radical, and CO2 goes away. From azo compound, when azo compound is heated at nearly 300 degrees centigrade, we got methyl free radical. Free radical can be generated with the help of photochemical reaction. When acetone in the presence of ultraviolet radiation generates methyl free radical with the help of redox reaction, that is generation of Fenton's reagent. When Fe is present in 2+ state and it is in the combination with hydrogen peroxide, we got OH free radical. Reaction of, now we are going to discuss reaction of free radical. First is propagation of chain reaction. So here just see your chlorine free radical is reacted with methane to generate methyl free radical. Now this methyl free radical is then attacked to chlorine to generate methyl chloride, and again new free radical, that is chlorine free radical. Second is polymerization. Free radical attack on double bond to generate new free radical, and this reaction goes again and again. That's why it is known as polymerization. In a termination reaction, just see in this case, when two free radical comes closer to each other, they are going to be a form a bond, and since there is no generation of other free radical takes place, that's why it is known as termination reaction. In our next class, we are going to see carbenes. Thank you very much.